Hey friends, coming at you for this week's first lesson for Tuesday. We're going to continue working on those exponential functions, and we're going to be looking at decay today. I'm coming to you from beautiful Houghton Lake. This is not Houghton Lake. That's the pond I grew up on, or one of the ponds I grew up on. You could admit, there's no leaves on the trees. You can see Houghton Lake down the street there, but I hope you're all doing well. I hope you enjoyed your weekend. We've had some beautiful weather. I know that sometimes that makes it hard to focus up on class, but maybe find a beautiful place outside to work on it where you still have some Wi-Fi or something, or um, write down the problems, go work on it, come back, put it in or something. Watch this video on YouTube on your phone if you have unlimited data or something, but I encourage you just to, keep after it. We've only got 2 weeks left, and, we're learning things the way math works. It's scaffolded. These things are going to really help you next year, and they're just never going to go away. All these building blocks that we do in math, they just keep coming back and coming back, so it's important we get it, we understand it. With that said, if you don't get something, make sure you hit me at my office hours. Now, I will probably still be up north, so the Wi-Fi is a little sketch, potentially, so I'm going to post a Zoom meeting, but if for some reason the Zoom meeting isn't working, we'll default I'll just be live on email. I'll have enough bandwidth to get emails in and out for sure. I know the Zoom is just like something kind of nice and extra we can do. It's not a requirement. So I'd like to try to do it, but just be a little flexible right in that moment. Check in Classroom for communications or email. If for some reason the Zoom isn't quite working up here, it's just the internet's pretty good, but not quite as good, and Zoom takes quite a bit up. So we'll cross that bridge when we get there. But any question you have, whether it's organizational, whether it's math, hit me up. It'll be Wednesday at 3:30, like it has been, and I should have all the information for that on Google Classroom. I'm running everything through Google Classroom. You know that. So let's get at this exponential functions. A good idea would be to have your calculator out. I think one challenge with some of these exponential functions is actually just using the tool correctly. So, as I'm getting answers, maybe make sure that with your calculator you can come up with the same answers. Remember, the calculator do order of operations, but you got to give it things like parentheses and stuff. So we're going to talk about exponential decay, and it's where something gets smaller. So last time, exponential growth, as it makes sense with the word, everything got bigger. So an exponential decay function might look something like this. And so the reason it starts bigger and then gets smaller, but it'll never be zero, is like I wrote in the text, if you thought of a loaf of bread, you cut in half, you cut it in half, you cut it in half. The chunk that you're cutting off is getting smaller because your whole thing is smaller. But you never could quite get it to be nothing. Even the tiniest little piece, you cut it in half, there's still half left. You cut that little teeny thing in half, there's still half left. So that's, right here, we'd call this kind of like approaching zero, but it would actually never be zero. And we're going to be dealing with some sort of decay factor in all of these instead of a growth factor. And it's going to be based on like a percentage or a fraction usually. And so if times 1 is no change, we're going to be dealing with things that are less than 1 to show a decay factor. So all of our decay factors are going to have to be numbers less than 1 in order to pump out answers that show decay or less. So we're going to look at a few examples. So here, in this first example, the population in fictional Dusty Depot is decreasing at 1.7% annually. If there are 2,300,000 people, how many will there be in 7 years? So I'm highlighting all the really important information. And you might remember the general exponential function is total equals initial value times, and now we're not doing growth today, but just for the sake of the equation, I'm going to put growth decay factor in the parentheses, either one, and it's going to be to an exponent, and that exponent is how many times. Okay, so the total, and I'll label this as total. The total equals our initial value times the growth or decay factor to an exponent of how many times it happens. And I know this is like a wordy equation kind of the way I show it, but like this can make sense with situation, right? This thing's happening this way this many times is all that to get a total. So let's start. Our total or end value is going to be our initial value of 2,300,000. Now, if it's decreasing by 1.7%, what you're going to want to do is take 1.7% away from 100%, and that gives us 98.3%, which is going to look like a decay factor of this. So what I did is I took this away from 100%, and that gives us our number less than 1. And remember, the reason that works is a 1.7% reduction leaves us with 98.3%. Let me say that one more time. A 1.7% reduction leaves us with 98.3%. And remember, that has to be as a percentage. So to make a percent into a decimal, I said that wrong. It needs to be made into a decimal. To make a percentage into a decimal, we move that decimal twice to the left. All right? So that is 98.3%. And then we're going to raise that to an exponent of how many times that happens. And it says annually, so that's each year for 7 years. Now, if it happened to say something like biannually, that means twice a year. Instead of 7, we'd have to have 14. But this is every year for 7 years. So that's my function. And to get my total, and I'm going to try to just say what I'm putting in my calculator. I'm putting 2,300,000. And then I put it in my calculator exactly how it looks. I use a parenthesis. I do 0.983. I close my parenthesis. And I raise it to the 7th power. Now, depending on your calculator, there's going to be a y to the x. Like I know on the cell phone calculator, I have a y to the x. On this TI-30X2S, which is my favorite, it's called a caret. It kind of looks like something like that. That's how you raise it to different powers. Don't do 0.983 times 0.983 7 times. That's going to be a lot of work. So if you type it in just how it looks here, it's going to pump out your decayed number. Now, for the go formative, you're going to need to round people to the nearest people. So let me write down what I got in my calculator. So that's the answer I got in my calculator. But for my answer, oh, that's going to be a 70. You need to round to the nearest person because we're dealing with people. And I'm going to be looking probably in the go formative for units like that too to get it right. So commas, units. If it's money, make sure there's a money symbol in front. Don't say like dollars as the word in the back. I probably won't have that as a correct answer. And then a good check is my final answer smaller than my original answer? And that is yes. So that's a good check. If it's supposed to be decay, let's make sure our answer is less than our starting value, you know? All right. So let's check out this one. We've got a herd of 1,200 dodo birds, and they're decreasing at a rate of 0.4% annually. How many will there be in 12 years? Let's see if these dodo birds go extinct, you know? So my new total is going to equal my initial value, 1,200. So if I have 100%, I take away 0.4%. That's going to leave me with 0.996, or 99.6%. All right, so remember, 100% is no change. If I take away 0.4, that leaves me with 99.6. And this is going to happen 12 times since there's 12 years. So each year, so 1,200 times 0.996 to the 12th. I type it in just like it looks there. That gives me an answer of 1143.65. But we don't have partial dodo birds, all right? We have only whole dodo birds. So you have to interpret your answer. It'd be 1,144 dodo birds. All right, so I would encourage you, make sure you're pumping out answers like this in your calculator before you go do the practice, just to make sure you're using your tool right. Yeah, and you're just going to have to find that exponent button that you maybe haven't used a ton yet. All right, let's talk about half-life. Half-life's pretty cool. I encourage you, look up some carbon dating stuff on YouTube. They use carbon dating, half-life for carbon dating. And really what it means is, I don't know if you know this, but elements decay. It means they decrease over time. They kind of break down, kind of. And so they've calculated how long it takes to have half of it. So cobalt-60, which that's just the name. That has nothing to do with how much. It's got a half-life for every 5.25 days, meaning there's half of it every 5.25. So you can backwards generate that to see how much you start with. It's kind of how they do carbon dating. So how much will be left? We got a 100-gram sample for 105 days. So how much is left is Y. I'm going to have my initial value. I started with 100 grams. Now my growth or my decay factor for this, it's half life. So it's 0.5. There's half of it over and over, okay? And then we got to find out how many times this happens. Well, I know I have 105 days. It happens every 5.25 days, so I have to do that division. And so that tells me it's going to happen 20 times. So that's my exponent. Note, it doesn't say 20 times anywhere in the information. I have to interpret my information. Every 5.25 days it cuts in half. I've got 105 days. Really what this number is how many times is it going to be cut in half? Okay, it's going to be cut in half 20 times. So then I'm going to slap that in my calculator. 100 times 0.5 to the 20th. And that leaves me with a really little number. So maybe I would tell you, like, go to the nearest something. If I gave this problem to you, for the homework, I would tell you to go to the nearest whatever. But that's just everything that the calculator pumps out. Okay? All right. Remember, feel free to pause, rewind, go back, send the link to your grandma, whatever you need to do with the video to make sure you're successful. Okay, this isn't intended to just one-time watch it. I know it's kind of quick. I got inspiration from this. I listened to a podcast the other day. Do you know that they're selling negative bonds? And what that means, you might not know what that means. What that means is you buy an investment that is guaranteed to give you a little bit less money than you put in the investment. And this is happening. So people find, like, what means is people who are buying these just want a place to hold their money, I think. And then it must mean that they think the economy is not going to improve. And this happened before COVID, too. I said Germany. I'm not sure what countries it's happening, but I know it's European. Anyway, what this means is you let them hold on to your money, and when it's time to collect your money, they give you back a little less. Traditionally, bonds and investments, you would get back more. That's the whole point of letting them hold on to your money. But they're selling out of these bonds even, which it blows my mind. I'm not buying any of it, you know. I'd rather put my money in a mattress than let someone hold on to it and give me less money, but don't anybody be coming trying to get my mattress. All right. Anyway, so you buy a negative bond. It's going to earn 0.3% less. Negative 0.3%, okay? And it's crazy, it's real. Something like this is kind of real. It's going to compound quarterly. That means 4 times a year, and you're putting 35 grand in there, and you need 6 years. So there's a lot going on here. So I'm always going to start with my initial value. In this case, it's 35 grand, okay? And 0.3% is going to leave me with 99.7%. That's my decay factor, all right? And that's going to happen quarterly for 6 years. So 6 years, 4 times a year. That's going to happen 24 times in this case, this fictional case. It's more complicated than this in the real world, but this is what we're working with for exponential decay. So I've got 35,000. I'm going to multiply in parentheses by 0.997, which is 99.7% of what's left. And that's going to happen 24 times. And that's going to leave me, when I come to pull my money out, that's going to leave me, and this is how you'd want to write it in GoFormative, $32,565.06. So we're going to round to the nearest penny. Whenever we're doing money, to the nearest penny, unless it says otherwise. So there we go. I let them hold on to my money for 6 years. They're going to give me back a little less. People are buying these, or government, probably like governments are buying these, or tycoons. I don't know why. They must have their reasons, but that's a real thing. Negative return bonds these days. Guys, thanks for listening. I hope you continue to do really well. Let you just all know I really miss you and wish I could be doing this with you. I hope you can tell I like this stuff, and it's important. It's one way we can explain the world around us. I don't know if you ever heard me say it before, but math is communication and math is creative. And it's just another way with all the subjects to explain and understand the world around us. So that's why I care that you do well and try your hardest, because it's going to serve you well in the future. So look forward to seeing some of you Wednesday maybe. Keep working hard and just know I got your back, all right?